Welcome to the deep dive. Today, we're zooming in on the electric motor, really the heart of the machine in any RC vehicle. We're sort of stepping past those basic throwaway motors you often start with.
Yeah, the sealed cans.
Exactly. And we're diving into Tamiya's world of, well, high-performance, serviceable power plants.
And that's really the key difference, isn't it? That dividing line.
Yeah.
You know, the standard silver can motor does its job. It's reliable enough to start.
Sure.
But the moment you want more, when you want sustained performance, maybe a deeper connection with how your car works, you look for serviceability, the ability to actually open it up, tune it, maintain it.
It's interesting, though, because we live in this age of brushless motors, right? They seem like the obvious upgrade, just raw power.
Oh, absolutely. Tons of power.
But people, top enthusiasts even, are still choosing these high-performance brushed motors. Why stick with that older tech?
It really boils down to control, I think.
Yeah.
Brushless gives you that, it's explosive speed and efficiency, no doubt.
Yeah.
But these specific Tamiya brushed motors, the ones you can service, they are often still unmatched for really fine, low-speed control.
Ah, okay.
Think technical rock crawling or scale driving where you need that super smooth throttle response, that predictable torque.
Right, finesse.
Exactly, finesse is the word. And for some classic chassis designs, reliability is just paramount. Plus, honestly, they're incredibly cost-effective in the long run.
Okay, so affordability, control, the ability to tune them. It's quite a combo. Let's unpack this then. What actually defines these performance motors in Tamiya's hop-up options catalog?
Well, we're talking about 540 size motors, the standard size. But these are specifically designed for, let's say, sustained peak performance.
Meaning you can fix them.
Precisely.
Yeah.
They allow for brush replacement, internal cleaning, that kind of thing. They're all upgrades over the stock motor, but their specs, the number of turns, their internal design, dictate what they're best at.
So they're quite specialized then. If I'm building, say, a car just for pure speed on a flat track, need really high RPMs, which one should I be looking at?
For that, you'd want the super stock RZ. That's the Sprinter. It's a 23-turn motor, but it's wound to really scream. We're talking 27,500 RPM.
Wow.
Yeah, it's all about velocity. And keep that in mind because its design, especially the brushes, is unique because of that high speed.
Okay, and what about its sibling, the Super Sock BZ? Is that just like a slightly detuned version?
Not exactly. It's also 23 turns, rated slightly lower at 26,500 RPM, but the BZ is really the off-road specialist.
How so?
Its key feature is practical. It has this detachable sponge cover over the cooling vents.
Oh, right, to keep the dirt out.
Exactly.
Yeah.
Keeps dust, grit, all that stuff out of the internals when you're running off-road. So you trade maybe a tiny bit of top-end speed compared to the RZ, but you gain a whole lot of durability in messy conditions.
Makes sense. Okay, but what if I don't need that absolute top speed?
Yeah.
Maybe I need more grunt, like for a heavier off-road buggy or a truck that needs torque.
Then you're looking at motors with a higher turn count. The Dirt Tune motor is a great example. It's 27 turns.
Slower RPM, but more torque.
That's the idea. It's tuned specifically for strong, consistent torque delivery. Great for climbing or powering through tough terrain. And it usually has features to handle the extra heat, like a heatsink end bell.
Gotcha. And there was another one you mentioned.
Yeah, the GT tuned. That's a 25-turn motor, around 19,000 RPM. It's a really popular, versatile choice, especially for on-road touring cars. Kind of an endurance champion, very reliable.
Okay, so RZ for speed, BZ for off-road durability, dirt-tuned for torque. That clarity is super helpful. Before we move on, you mentioned something about a vintage one.
Oh, right, a little bit of trivia. The old Dynatech 01R. It's a classic, fully rebuildable.
Cool.
Yeah, but the catch is, if you're lucky enough to have one, finding its specific replacement brushes today. Well, good luck. They're incredibly rare, basically discontinued. Item number 53003 if anyone's hunting.
A collector's challenge then.
Definitely. A modern superstock is much easier to keep running day to day. And speaking of keeping them running, let's talk about the brushes themselves. This is where the engineering gets really interesting. There are basically two main types, two architectures in these Tamiya motors. And knowing the difference matters.
Right, you mentioned standard and laydown brushes.
Exactly. Most of the motors we talked about, the BZ, the GT Tune, the Dirt Tuned, they use what are called standard or stand-up brushes. The replacement parts, like item 53581, are common.
Okay, standard setup.
But then there's the specialized laydown brush design. You only find these in the really high-revving motors, specifically that Superstock RZ we talked about. Item 53483 for those.
Wait a second. If the standard brush works fine in the BZ, which hits 26,500 RPM, Why did they engineer a whole different laydown design just for the RZ's extra 1,000 RPM? Seems like a lot of effort for a small game.
But it's not just about the RPM number, it's about what happens at those extreme speeds. It's a phenomenon called brush bounce.
Brush bounce.
Yeah. When a standard stand-up brush is spinning against the commutator at, say, 27,000 RPM or more, the physical forces can actually cause it to slightly lift or bounce off the copper segments.
And that's bad.
Very bad. Every time it bounces, you lose electrical contact momentarily. That means inconsistent power delivery, sparking or arcing, which damages the commutator and the brush.
And wears things out faster.
Exactly. So the laydown design is this really clever engineering fix. It changes the angle the brush contacts the commutator and alters how the spring crusher works.
How does that help?
It essentially forces a much more stable, firm, and consistent connection even under those extreme rotational forces. It stops the bounce.
So it ensures the power keeps flowing smoothly, right to the RZ's limit.
Precisely. Reliable power delivery right when you're demanding peak performance. It's physics solving an electrical problem.
That's fascinating. Specialized physics for sustained power.
But all that clever engineering doesn't mean much without proper care.
Right. Call.
If the design is the theory, maintenance is the practice. So for someone wanting to step up to become more of a technician than just a driver, where do they start with servicing these?
Okay, absolutely critical first step. Before you take anything apart, you must mark the motor's timing alignment.
Timing alignment.
Yeah. You need a clear, precise line that goes from the motor can across the seam onto the end bell. Use a permanent marker, maybe even a light scribe mark.
Why is that so important?
Because that mark is your only guide to putting it back together correctly. It ensures the timing is reset to neutral, 0 degrees. If you reassemble it slightly off, you mess up the motor's performance, maybe even damage it. Skipping this is the #1 rookie mistake.
Got it. Mark first, disassemble second. Okay, so tools are out, mark is made. During disassembly, what's the biggest hazard? What flies across the room?
Definitely the brush springs. They're tiny, they're delicate, and they are under tension holding the brushes in place.
Right.
When you unhook them, be really careful. They will try to launch themselves into oblivion.
Yeah.
Best bet is to work in a contained space, maybe over a tray or parts dish. Seriously, losing one is incredibly frustrating.
Good warning. Okay, motor's apart. We've got the end bell off, the armature out. What are we looking at on the commutator, those copper bits? The commutator is like the real heart of the motor's electrical side. You want to see smooth, polished copper segments. That's normal wear.
What are the bad signs?
You're looking for pitting little divots in the copper. Deep grooves are bad. And any dark, burnt-looking spots are a sign of excessive heat or arcing. All those things mean poor contact and lost performance.
Okay. Let's say it's not terrible, just got that typical layer of dark carbon dust from running. Is there an easy fix? That famous trick?
Ah, yes, the classic pink eraser trick. And honestly, it works surprisingly well for light cleaning.
Just a regular pencil eraser.
Yep, a standard pink pencil eraser. You just gently rub the commutator segments. The rubber lifts off that surface layer of carbon dust without really scratching the copper underneath. It leaves it looking bright and conductive again.
Simple but effective. But what if the wear is more significant? What's the next level up?
For a truly perfect surface, especially if there's minor grooving, the pro technique is commutator lathing. You need a special tool, a comm lathe.
Okay, that sounds more involved.
It is. It's more for the serious racer or tuner. It actually cuts a tiny amount off the commutator surface to make it perfectly round and true again. That gives you the absolute best brush contact possible.
Right. And one more thing while it's apart, lubrication.
Crucial, especially if you used motor spray or cleaner inside, because that strips everything off, including oil.
So what needs oiling?
The bearings or bushings at either end of the armature shaft. Just 1 or 2 small drops of light bearing oil directly onto them after cleaning. Keeps things spinning freely and lasts much longer.
Okay, maintenance done, new brushes installed. Now the final critical step, the braid-in. You mentioned there's a lot of bad info out there about this.
This is where myths really persist.
Yeah.
But the break-in, or seating the brushes, is arguably the most important thing you do for the longevity of those new brushes.
What's the goal? Why do we need to break them in?
Simple geometry, really. A new brush base is flat, the commutator surface it runs on is curved, it's round, Seating is the process of gently wearing the brush face so it perfectly matches that curve of the commutator. This maximizes the surface area touching, which means better electrical current transfer and, importantly, less sparking.
Okay, makes sense. So what is the correct way to do it for these Tamiya 540 motors? The expert-approved method.
The correct and safest method is the dry break-in, no water involved.
Dry break-in. How does that work?
You connect the motor with no load on it, just the motor itself, to a low-voltage power source. Something like a 2-cell or 4-cell AA battery holder works great. Or a power supply set low, between maybe 3 and 6 volts.
Okay, low power.
Yep. Then you just run the motor for maybe 2 or 3 minutes in one direction. Then swap the wires, reverse the polarity, and run it for another 2 or 3 minutes in the other direction.
Then that's it.
That's it. That slow, controlled running under low voltage gently shapes the brush face to the commutator without excessive wear or heat. It creates that perfect contact patch.
So why on earth do you hear about people dunking expensive motors in water to break them in? Where did that come from?
Ugh, the infamous water break-in myth. It needs to be shut down, especially for these 110 scale motors. That whole practice comes from a totally different world. Tamiya Mini 4WD racing.
The little slot car things.
Kind of, yeah. Those use tiny, very inexpensive motors that are almost considered disposable. For those tiny motors, maybe the water helps flush out debris quickly, I don't know. But for a larger, more expensive motor like a super stock BZ or RZ, water break-in is actively harmful.
How so?
Think about it. Water itself, especially if it has any minerals, acts like a mild abrasive when mixed with brush dust. It dramatically speeds up wear on both the new brushes and the commutator. Plus, you're introducing moisture right into the bearings.
Which leads to rust.
Exactly. It promotes bearing rust and corrosion. It's just a bad idea for these motors. Always stick to the gentle, low-voltage dry break-in.
Okay, that's crystal clear. Dry break-in is the way. So let's tie this all together. We've gone through the different motors, the brush tech, the maintenance. What's the big picture? The strategic advantage of choosing one of these serviceable motors.
Well, first off, the economics are pretty compelling when you look long-term.
How do you mean?
A standard sealed can motor, once the brushes wear out, that's it. The whole motor is basically trashed. You have to buy a whole new unit.
Which costs what, like $35, $50 maybe?
Around that, yeah. But with a serviceable motor, when the brushes wear out, you just buy new brushes.
And how much are those?
Maybe $5 to $16 a pair, depending on the type. It's a fraction of the cost. So the motor itself becomes a long-term investment, not a recurring expense. You just do minimal upkeep.
That's a huge difference over the life of a vehicle. And performance-wise, you mentioned resetting the curve.
Yeah, think about how performance degrades. As the brushes wear down, the spring pressure holding them against the commutator decreases.
Right, less contact force.
Which means electrical resistance goes up, contact gets less consistent, you start getting more sparking, power drops off. It's a gradual decline.
A one-way street for a sealed motor.
Exactly. It just keeps getting worse until it dies. But with a serviceable motor, every time you put in new brushes and clean the comm, you essentially reset that degradation curve. You bring the motor's performance right back to, or very close to, its as-new state. You can keep doing that almost indefinitely.
So you maintain peak performance potential for much, much longer.
Potentially for the life of the chassis, yeah.
And beyond the cost and performance, there's that learning aspect you touched on earlier.
Absolutely. Moving from just driving the car to actually taking the motor apart, cleaning it, replacing parts, that's a huge step.
You become a tuner, not just an operator.
You got it. You learn to diagnose problems by looking at how things wore down. You see the commutator discoloration and understand what it means. You gain this direct, hands-on understanding and control over really the most critical performance component of your vehicle. It's empowering.
It really connects you to the machine on a deeper level. So we've covered the RZ for speed, the BZ for dirt, the dirt tuned for torque. We've seen the smart engineering and the laydown brush designed for high RPMs, and crucially, why dry break-in is the only way to go. Seems like a takeaway is, if you're looking for performance beyond that basic kit motor and you're ready to get your hands a little dirty.
Yeah, if you're ready to embrace that hands-on approach, then upgrading to one of these serviceable Tamiyas is the logical next step. Stop buying disposable motors and invest in something tunable, something that lasts.
It feels like these rebuildable motors are almost a statement piece in today's world, where so much tech is sealed and meant to be thrown away.
It's true. They represent that core RC hobby ethos. The satisfaction comes not just from the driving, but from the building, the tuning, the understanding.
So here's a thought to leave everyone with. We talked about that vintage Dynatech 01R and how its serviceability makes it potentially valuable, even if parts are scarce now. Looking at the current lineup, the RZ, BZ, GT tuned, which one do you think, 20 years from now, might become that sought-after, maintainable classic, precisely because it was designed to be taken apart and kept running? Which one holds that long-term legacy value?
Yeah.
It's often those serviceable details that define what lasts.